Assalamualaikum warahmatullahi taala wabarakatuh and a very good day to everyone. Okay, my name is Mohammad Fikri bin Mohammad Azam. My supervisor is Dr. Faizah Betty Muhammad Yasin and the title is Stability and Characterization of Nanographene Oxide with Pluronic F127 to simulate in Vivo condition. Okay, move to introduction. Graphene oxide have been prepared originally using classical methods established by Brody, Standermeyer and Hammers. Okay, so far Hammers method is the famous methods nowadays. Okay, so this, as you can see in figure 1, methods to synthesis graphene oxide by Hammers methods. Okay, including improved Hammers method and modified Hammers method. Okay, so here are the methods, different methods that I mentioned earlier. So Hammers method, improved Hammers method and Hammers modified methods. So in this method, preferred using improved Hammers method due to simpler protocol, higher yield and no toxic gas evolution during preparation. Now Pluronic F127. Okay, so this is the structure of Pluronic F127 and consists of polyethylene oxide, polypropylene oxide and polyethylene oxide. Pluronic F127 able to see damage cell membrane with low toxicity. Now move to graphene oxide and Pluronic F127. Okay, so it state here that graphene oxide has incredible application potential in the field of blood copolymer, which is referred to the PF127. Now move to problem statement. Previously, GO has been produced by using dry method, which is CVD. Nowadays, we are using wet method, which is Hammers method, and in this project we are using improved Hammers method and will get graphene oxide with high surface area. So GO will be further processed until it get nano size and then will be functionalized with Pluronic F127. Okay, next move to objectives. Objectives are divided into 3 main objectives. So the first objective is to evaluate and characterization the stability of NGO-PF127 in Vivo condition. Okay, for A, it has 3 sub-objective. The first one is GO using improved Hammers method, synthesis nano GO, synthesis decorated NGO with PF127. Next, to evaluate and characterization the stability of NGO-PF127, and last one is to evaluate NGO-PF127 simulated in Vivo condition. Now literature review. Okay, so this literature review is to compare with the testing part, because this literature review is referred to the AG nanoparticle, but in this experiment we are using NGO, but the method used in this literature review is same as in this project. Move to methodology. Okay, so in figure 1, state that overall method of the experiment start with synthesis GO, and the second one is characterization on GO by using Raman spectroscopy and FTIR. Next, continue with NGO by using probe sonicate. Next, characterization on NGO by using nanosizer, FTIR and zeta potential. Functionalize NGO-PF127. Next, characterization on NGO-PF127 by using nanosizer, FTIR and zeta potential. Next, testing in Vivo condition by using simulated gastric fluid and simulated intestinal fluid. And last one is characterization on NGO and NGO-PF127 by using nanosizer or DLS. Next, to synthesis GO, these all materials, chemicals, apparatus need to be considered. Okay, so these are the method to synthesis GO. Okay, next, these are the methods of synthesization of NGO. Then we need to synthesize NGO and PF127 by using this method. Okay, now this is the method to synthesis SGF. This method need to control the pH until it get 1.2. Next, for the SIF, the pH need to be controlled until it get 6.8. Okay, next, as you can see in figure 10, this is NGO and NGO-PF127 that has been tested in SGF and SIF. So this procedure need to be run in water bath incubator at 37 Celsius. Okay, now move to result and discussion. Okay, so this is the synthesization of GO. The color of the mixture in figure 1 will change to brown at the end of the reaction, indicating the completion of the oxidation process and the production of oxidized graphite. Okay, now, as you can see in figure 12, this is the graphene oxide produced, and the weight is about 2.355 gram. Okay, to make sure the GO is pure, so there are two characterization on GO has been done, which is Raman spectroscopy and the other one is FTIR. Okay, so for the Raman spectroscopy, actually the results obtained approximately to the literature review. Okay, so this is the graph of Raman spectroscopy. Okay, now FTIR. Basically, FTIR is used to determine CO, OH, and C double bond C. Okay, so actually the result that has been obtained approximately to the journal. So this is the FTIR spectra on GO. Okay, so in the red circle, wish to show that OH, C double bond C, and CO. Okay, now synthesization of NGO. So this method is used top-down processing because we are using graphene oxide in micro size and further process until it get nano size. Okay, now characterization on NGO, because this is the way to make sure the NGO is pure. Okay, so there are about 3 characterization has been done, which are nanosizer, zeta potential, and the last one is FTIR. Okay, so the result for nanosizer, which is 126.9 nanometer with 0.274 PDI. So it is good because the PDI should be in this range 0.08 until 0.7 because this is the best operate over. And the zeta potential, the result is about negative 15.6 millivolt because as RV mentioned in the journal, this value is in relatively stable, so this is good. Okay, so in this figure 16 and figure 17 is to show the size distribution of NGO by volume and the zeta potential of NGO. Okay, now move to FTIR spectroscopy comparison between GO and NGO. Okay, actually the result for GO and NGO should be same because it's only differ by the size. Okay, so as you can see here, this is the FTIR spectra of GO and NGO. Okay, so as you can see in the circle, actually the result for OH, C double bond C, and CO actually is same for the GO and NGO. So the result that has been obtained actually is good. Okay, so move to synthesization of NGO PF127. Okay, so as you can see in figure 19, NGO PF127 is produced in dark brown color. Okay, now move to characterization on NGO. Okay, so for the nanosizer, the result is about 288.2 nanometer and the zeta potential is about negative 13.02 milliwatt. Okay, so this results is about approximately to the journal, and which is good. Okay, now move to FTIR spectroscopy comparison between PF127 and NGO PF127. Okay, actually, PF127 and NGO-PF127 give the same value as the journal. So this is good. So in figure 22, okay, so this is the FTR spectroscopy of PF127 and NGO-PF127. Okay, as you can see in the circle, the result for PF127 and NGO-PF127 actually same, because it consists of the same component of PF127. Next, move to testing in SGF and SIF. Okay, the samples use NGO and NGO PF127. Okay, so as you can see in figure A and figure B, this is the water bath incubator operate at 37 Celsius. Now move to the important part, which is the characterization on NGO, NGO PF127 in SGF and SIF. Okay, so according to some journal, they only focus about range 1 hour until 8 hours for the testing parts due to the particles start to agglomerate and become in bigger size, which was achieved 1 micrometer and above. Okay, so according to another journal, it state that they done only for 180 minutes for the testing part of the nanoparticle that they are using is Ag nanoparticle in SGF and SIF is due to when in SGF with pH 1.2 it became unstable, which is 1 micrometer once it reached 180 minutes, and for the nanoparticle in SIF, which pH 6.8, the size only reached until 200 nanometer, which means still stable. But then, when they run until or maybe more than 180, the SIF, the nanoparticle inside the SIF will become unstable and it reach 1 micrometer. Okay, now as you can see in table 2, this is the DLS or nanosizer data for NGO, NGO-PF127 tested in SGF and SIF using water bath incubator at 37 Celsius. Okay, so as you can see, the nanoparticle in SGF and the SIF, the result start to become in bigger size, which is about 1 micrometer once it reach 12 hours and above. And the result of the experiment actually is approximately same as the journal. Okay, last but not least, we move to conclusion and recommendation. Okay, so the synthesization of GO using improved Hammers method, NGO and NGO PF127 was proven to produce a high quality GO. There were 28 samples consist of NGO SGF, NGO PF SGF, NGO SIF, and NGO PF SIF were running for 7 times interval. The diameter size that in stability condition only can be obtained until 8 hours experiment. Okay, so instead of using NGO, actually we can use RGO because lack of OH, C double bond O, and COOH, and RGO is less toxic compared to the GO. Okay, so to make sure the diameter size of the nanoparticles still in nano size, so need to use water bath sonicate about 30 minutes or more, so the size will become homogeneous and give good diameter size. Okay, move to the reference. Okay, so these are the reference that has been used throughout the experiment. Okay, I think that's all from me. Okay, thank you.